Math Day, great day, Math Lead ladies. Welcome to Mathematics Lead channel, where we turn your worries into mastery. I am Francia, and together let us have fun while learning. Good day, everyone. Today we're going to explore three powerful algebraic tools that help us understand and analyze polynomials more efficiently. The remainder theorem, factor theorem, and rational root theorem. Here's our learning objectives. At the end of the lessons, the students should be able to prove and explain the remainder theorem, factor theorem, and rational root theorem. Apply these theorems to determine polynomial remainders and identify roots and factors. Appreciate the role of theorems in simplifying algebraic analysis and problem solving. First, we have engaging activity. To begin our lesson, we will explore how polynomials are connected to real-life situations. Today, we will understand three important concepts: the remainder theorem, factor theorem, and rational root theorem. Let's start with a simple and familiar example. Imagine that you have 14 chocolates and you want to share them equally among three friends. The question is, after sharing, how many chocolates will be left over? Keep this situation in mind as we connect it to algebra. We represent the total number of chocolates as a polynomial f of x is equal to 14. The number of 3 represents the number of friends, so we divide by x minus 3. Using the remainder theorem, we evaluate f of 3, which give us 14 when we divide 14 by 3. The remainder is 2. The remainder tells us that 2 chocolates are left over after sharing. Just like in real life, the remainder theorem shows us what remains after division. Now, let's move on to the factor theorem. Imagine you have 6 trees and you want to plant them in equal 2 rows. The question is, can we arrange the trees into rows of 2 without any leftover? We model this situation using the polynomial f of x is equal to x squared minus 5x plus 6. To check if 2 works perfectly, we evaluate f times the quantity of 2. Substituting, we get 2 squared minus 5 times 2 plus 6 is equal to 0. Since the result is 0, x minus 2 is a factor of the polynomial. This means the trees can be arranged evenly. The factor theorem helps us determine when division is exact or a perfect fit. Next, look at the rational root theorem using saving example. Suppose your saving goal is $2 and you save a fixed amount each week. We want to know which amounts will allow you to reach the goal exactly. We represent this situation using the polynomial f of x is equal to x squared minus 3x plus 2. Using the rational root theorem, we list the possible roots plus 1 and plus 2. When we test these values, we find that x is equal to 1 and x is equal to 2 are roots. These values show the possible weekly savings amount that work perfectly. Let's move on to our activating knowledge. The remainder theorem is a mathematical shortcut that states when a polynomial f of x is divided by a linear factor x minus a. The remainder is equal to f of a. This theorem provides a quicker way to find the remainder than performing long division, as it simply requires evaluating the polynomial at a specific value. In factor theorem is an algebraic rule stating that a polynomial p of x has a factor of x minus a is and only if p of a is equal to 0. This means if substituting a value a into a polynomial result in 0, then x minus a is a factor. Substituting a will result in 0 if it is a special case of the polynomial remainder theorem. Last, we have rational root theorem. It helps us identify all possible roots of a polynomial with integer coefficients. It states that any rational root expressed as p over q must have p as a factor of the constant term and q as a factor of the leading coefficient. Let's start with our given polynomial f of x is equal to x squared minus 5x plus 6. Our goal is to factorize this polynomial completely and identify its roots. First, we apply the remainder theorem. We are dividing the polynomial by x minus 2, so we substitute x is equal to 2 into the function. Solving, we get f of 2 is equal to 2 squared minus 5 times 2 plus 6, which is equal to 0. This means the remainder is 0. Next, we use the factor theorem. The factor theorem tells us that if f of a is equal to 0, then x minus a is a factor of the polynomial. Since f of 2 is equal to 0, then we can say that x minus 2 is a factor of f of x. Now let us list the possible rational roots using the rational root theorem. The constant term is 6, so its factors are plus or minus 1, 2, 3, and 6. The leading coefficient is 1, so its factors are plus or minus 1. Therefore, the possible rational roots are plus or minus 1, 2, 3, and 6. Last, the developing competences. Now that we already understand the remainder theorem, factor theorem, and rational root theorem, let's further develop your skills in applying these concepts. Since you already have an idea of how these concepts relate to real life, we will now have an application activity through group work. Class, you will work on in groups for an activity that will help you understand how polynomials are used in real-life situations and how different theorems help us analyze them. Each group will be given a real-life scenario such as sharing items, packaging products, arranging seats, or distributing money. Your task is to translate that situation into a polynomial model. First, your group will create a polynomial that represents your chosen scenario. Make sure that polynomial clearly models the situation you are describing. Number 2, you will use the remainder theorem. This will help you determine if there is something left over when the situation involves division. Division, for example, you will evaluate the polynomial a specific value to see if there is remainder and explain what that remainder means in your scenario. Number 3, after that, you will apply the Fokker theorem. These steps allow you to check whether a certain value results in a perfect division. If the remainder is 0, then that value is a factor of your polynomial. You must explain what a perfect division represents in real life. Then your group will use the rational root theorem. From this theorem, you will list all the possible rational roots of your polynomial, choose at least one possible root and verify it by substitution. Finally, you will factor your polynomial completely. Once you're done factoring, explain what each factor or root means in the context of your real-life scenario. This is very important because it shows your understanding beyond solving. Remember, your explanation should connect mathematics to real life. Be ready to present your work and explain your reasoning clearly. Everyone in the group should be participate. By the way, this is the criteria you will use. Thank you.